All right, here's your retake video for learning targets 1, 2, and 3 from Unit 3. On the front part here, no one, I mean, not really too many people had issues with this on the test. Um, but just to go over it real quick, this first one here, there is seemingly no pattern or trend to these. This would be C, relatively no correlation. Um, in this second example, as the x variable increases, the y variable decreases. That makes this a negative correlation, and there is some spread to these. So I would call this a weak negative correlation. Um, Similar down here, it is negative. This one I would call strong though. The points are fairly close together, meaning that there's not a whole lot of variation in the data. So I would call this a strong negative. And then this last one, again, kind of spread, but this is a positive correlation. As one variable increases, so does the other. So I would call that B, a weak positive correlation. Here's where most people on the test kind of went wrong. Or at least like got some points marked off. Um, you needed all four parts of this. I think everyone first of all identified this as positive. Um, Most people said this was strong. You could have said weak. If you said weak, you probably needed to point to um, some kind of outliers here. You could probably call this an outlier too if you wanted. It doesn't look like it quite fits the trend of the data. Um, so you could call those outliers if you wanted to say that this was weak. You would just need to say something about these outliers. Otherwise, if you called it strong, you would need to probably talk about how there's not a ton of variation between these points, that all these data points are fairly close together, and none are too extreme. Um, in a real world context, this is your little part 4 here. Because this is positive, we're looking for something where as the population increases, so do the number of pizza restaurants. Um, and again, most people did fairly well with that. But as population increases, restaurants increase. The last part then, the distinguishing between the correlation and the causation, this is probably where the most issues came up. Um, if you said a correlation, again, this is one of those where you could have gone either way. If you said a correlation, um, be prepared to defend that with something along the lines of, um, just because there's a higher population doesn't necessarily cause more pizza restaurants. A higher population could correlate because more people, there's probably just in general more restaurants. Um, and so typically, maybe it's a bigger city. So typically bigger cities have more restaurants. Um, Maybe you could talk about how if you're in a big city, there are going to be tons of there are going to be tons of more like corporate restaurants, tons more chain restaurants, but there are also going to be a lot of kind of small business kind of places open up. So you kind of have to dig into the actual concepts a little bit. If you wanted to say that this was a causation, you needed to somehow explain to me how population could directly cause the number of pizza restaurants to open up. And if you wanted to say something like more people in a town means that there's much more demand for food, and that demand for food, people are always wanting pizza. Um, so someone comes into a big town that's growing, 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 and they want to make money, so they open a pizza restaurant because they see the population growing. That could be a direct cause for why they opened the pizza restaurant. So, just basically giving an explanation one way or the other of why one might cause the other, or are they just a simple correlation? In preparing for learning target one for your retake, I'd like you to answer these 4 questions. First of all, just simply what did you do wrong in the test, or where'd you get marked off, or whatever. And then just describing sort of how you know um, these different things, how you know something is strong or weak, how you know something is positive or negative. Um, how do you distinguish? Well, that should be an H. How do you distinguish um, between causation and correlation when you're looking at 2 variables? And if you want to give an example there, or a couple examples there, that might help um, explain your answer. But have these done before you come and ask about taking a retake. Learning target 2, 2 and 3 were both together on your test. Again, this first part most people got right. If we're looking at these closely spaced dashes, this line, this is obviously not a line of best fit um, because it really doesn't even follow the same trend as the data. Um, line M here, it follows the trend, but it's kind of all along this lower part. Like there are a lot of other dots on top of it, and not really many below. So it kind of fits the trend, but it's really on the lower end of all the data. Um, so really, line P, this solid line here, is the best fit line for this data. Moving on to this second part, this kind of goes back to Unit 2, Learning Target 9 from Unit 2, in that you are looking for the slope of the line based on 2 points, essentially. And so you kind of pick out your 2 points, and then draw a line through them. And then once you've got your line, you have the 2 points, and so you kind of have to estimate a little bit, but you can use your 2 points to find the slope. And so my 2 points here look like, 4. We'll say 4 comma 55. And we'll say that this one was 68 comma 80. To find the slope then, remember this is change in y over change in x. 80 minus 55 over 68 minus 4. That gives me a slope of about 25 over 64. And if we kind of simplify that into, or not simplify that, but if we kind of find that as a decimal, because a lot of people did that on the test, that would be about 0.39. And then what that means, this sort of gets into actually the learning target 3, but I'll go ahead and say that for this test example. For what this means in terms of the problem, and you can look at it one of 2 ways. You can say that the change in y, again, y is temperature. So you can say the temp increases 25 degrees for every 64 new people. Every time 64 people walk into the room, the temperature increases by 24 degrees. That's one way you can look at it. Or if you're looking at this decimal, you can say the temp increases 0.39 degrees for every one person that enters the room. Those are equivalent sayings. Those are essentially saying the same exact thing. Number 5 here, you need to take one of your points, y equals 0.39 times x plus b. And again, this just goes back to learning target 9. We're solving for b, so we've got, let's use the first point. So we'll go 55 equals 0.39 times 4 plus b. And we get b equaling, let's see, 0.39 times 4. B equals about 53 degrees. When I calculated it, it was 53.44, but we'll round it to 53 degrees. What this means in terms of the problem is that when there are 0 people in the room, the temp is still 53 degrees. Okay, a lot of people said that that 53, kind of switched it around, saying that 53 people would need to be in the room in order for it to be 0 degrees. If you think about, if we kind of extend this graph and look at right here, that gives us a rough estimate of our line. This is our calculated y-intercept, but right at this point, there are 0 people in the room. So don't lose track of where your variables are at. This x variable is number of people in the room. At this point, there are 0 people in the room. The temperature right here, that's where we get the real interpretation, which is 53 degrees. Here are your practice problems for learning target 2. You're going to be calculating a slope and a y-intercept. All the coordinates for the points on this graph are right over here, so that'll help you in calculating it. So if you need learning target 2, go ahead and pause and do those. If you need learning target 3, there are your questions for learning target 3. So go ahead and do whatever practice problems you need to do. Bring them to us and we will give you the retake.